Hello, everyone. Welcome back to another episode of Tantra's Mantra, where we go behind and beyond the tech news headlines. I'm your host, Prakash Sangam, founder and principal at Tantra Analyst. Today, we once again take a look at vRAN and Open RAN and what's happening there. We have done lots of episodes on this subject, but today we'll specifically focus on the compute architecture part of it, looking at what are the major consideration for operators and the industry, as well as what is the best compute architecture and why. As many of you might know, vRAN and Open RAN consists of two functional blocks, namely DU, distributed unit, and RU, radio unit. In legacy architecture, these functions or functional blocks were implemented in proprietary hardware and software, so you cannot separate them. And it's all changing with vRAN and Open RAN. And the initial thought when the industry started working on these things was you could use regular off-the-shelf generic compute, primarily CPU, for all the functions in these blocks, DU and RU. But they soon realized that the RAN workload itself is so complex and needs very low latency and almost real-time processing. CPU may not be the best solution for it for cost and power efficiency reasons. I've written a detailed article on this subject. I'll include a link to that article in the description of the podcast. So please do check it out. So, yeah, coming back to cost and efficiency reasons, obviously, cost efficiency is always a concern no matter what industry you go. But nowadays, power consumption of networks and bringing efficiency in terms of energy consumption has become a major consideration because of climate reasons and so on. And of all the energy operators consume, more than 80% is spent on RAN. So power consumption in the RAN and the compute in the RAN itself is a big deal. So the question becomes, how do we achieve maximum efficiency there, using the best computing architecture? And there are a couple of computing approaches, and there are obviously both pros and cons with these approaches, and a lot of questions on why, what, and so on. And we have an expert with us today to discuss all these questions, and that is Joel Brand, a senior director of product marketing at Marvell Technology. Regular listeners of the show might remember that Joel was on one of our previous episodes a couple of months ago discussing the vRAN and Open RAN. But this time we will go a little bit deeper and address some of the more fundamental as well as in-depth questions on the subject. Joel, welcome back to the show.
Thanks for having me back.
All right. So, as I said, now we have done a few episodes on vRAN. This time we'll talk about the more specifics and also Marvel's product announcements and partnership announcements done at Mobile World Congress, which were really interesting. And with that, let's get started. So, Joel, could you give us a quick introduction of what you do at Marvel?
Yes, of course. I'm responsible for the wireless portfolio as part of the compute and custom business unit at Marvell. This is a business unit that has a fairly broad portfolio of SoCs to address the wireless market, ranging from the digital front end through the massive MIMO beamformer to the L1 processor and the L2 processor. So we are serving the majority of wireless customers today with variety of options.
Very well. And I think it's both customers with legacy architecture as well as vRAN and Open RAN architecture, correct?
Absolutely.
Well, so vRAN, Open RAN, of course, started with a lot of hype because of geopolitical and other reasons. There's a lot of interest as well to support that hype. There's a lot of traction. But what is the view from the ground? First phase of 5G is almost complete worldwide, using mostly legacy architecture, other than a couple of smaller opportunities like Rakuten and something that's coming up with Dish. Will vRAN, Open RAN then target the expansion part of that market, or the second phase of 5G? I would call, addressing massive IoT and URLLC, those kinds of opportunities and so on. What is your view?
I tend to separate between Open RAN that typically refers to the front hall interface, the open interface between the RU and the DU. There is traction, there is evolution there also in the standard organizations, different splits, there's a variety of 7 point something splits, 7.1, 7.2, A, B, C, D. 7.3. There are all kind of options, and they're still evolving in the market, and different splits are likely to be mapping to different type of deployments, whether it's a sub-6 deployment, millimeter waves deployments. So we are, we are still in the process of definition and kind of finding the best match for solving the right problems.
Mhm.
On the vRAN side, the goal is completely different. The goal on the vRAN side is to take advantage of IT technologies and cloud architectures that have been perfected primarily by the hyperscalers over many years there. And also there, we are seeing some progress with different tools to manage the network. We're seeing some traction. We're seeing some new entrants who are trying to gain some momentum in this market.
Mhm.
But one way or another, this is a very small portion of the market today, and it will take a while before it will gain meaningful market share.
Mhm.
Primarily because we are dealing with an environment that is very reliability and availability focused, and it takes time to move things from one architecture to another.
Yeah, indeed. I think the forecasts are like it will be 20% of the overall market in next few years. So yeah, it's interesting. And the what are some of the operator concerns you hear about vRAN and multi-vendor Open RAN? I think vRAN, which is disaggregation and a cloud native part, I think that has lots of traction. Lots of people are doing it. I think the questions are still on multi-vendor Open RAN, right?
That's right. That's right. So on the Open RAN, it's the questions there is always who is responsible.
Correct. Yeah.
The minute that you mix and match vendors, there are a lot of issues.
Yeah. Single throat to choke, right? Yeah.
Yeah, there are a lot of issues around liability and reliability as a result of it, and that's an important topic, right? At the end of the day, these networks must remain very available, very reliable. On the vRAN, the concerns are around costs. Originally, this architecture was supposed to reduce
Hmm.
the cost of building these networks, and it turns out that that's not exactly accurate.
Correct.
And that comes down to something that I'm sure we'll talk later in the program, that the idea of using standard servers in an environment where SoCs were perfected over many years to serve that specific environment is taking the cost in the wrong direction.
Not later. We'll jump right into that questions, to the architecture question specifically. So, why generic compute is not enough? Some infra players are actually, swear by it and working on it as well, right? See how good that pans out. But in your view, why do you think the generic CPU architecture is not good enough for RAN workload?
Generic compute is a fantastic tool. It's a tool that enables you to run an application even before you know what the application will need.
Hmm.
You can run TikTok, you can run a web browser, you can run anything you want.
Yeah, that's why it's generic, right? Yeah.
That's why it's generic. But when you know your workload,
Yeah.
an optimized solution will always be better. That's by definition of an optimized solution.
Hmm.
Many times, optimized solutions are not justifiable, right? When the application is too small in volume, it doesn't make sense to develop optimized compute. But the RAN is a very large market, and it does make sense to develop optimized compute, and companies have developed optimized compute, Marvell specifically,
Hmm.
and it's a better solution. Now, it's true that there are some of our competitors who are developing general compute. They would prefer that. Naturally, that's what they have to sell.
Mhm.
That makes a lot of sense. In terms of the vendors who are serving the operator community, I haven't seen any one of them jumping to volume deployments of solutions on general purpose compute.
Of course.
Again, simply because it's not really an affordable and power efficient solution.
Yeah, I think Ericsson is the one really behind it in terms of major vendors, and we haven't seen a lot of deployments. I think all they announced was one site, I think, with Verizon. We'll see how that progresses. So let me play a devil's advocate here. So the whole idea of vRAN was to one disaggregate and also use as much off the shelf hardware, right? So that there is no lock in proprietary software hardware and that kind of stuff. But by using optimized hardware itself, as you're mentioning, you are going back to kind of legacy approach itself, right? That you have a specific specialized proprietary or not hardware and a software which is tied to the hardware as well, right? So isn't that beating the purpose of vRAN approach itself then?
That goes back to the question of what exactly is the purpose of vRAN.
Mm-hmm.
And the purpose of vRAN, in my mind, is mostly in order to take advantage of cloud architecture and IT technologies.
Mm-hmm.
If you think about building a cloud,
Mm-hmm.
take a look at Amazon AWS. They're using very unique solutions, very unique processors, right? They are very proud of their Graviton solutions.
Mm-hmm.
Is this an off-the-shelf solution? Can you buy that
Yeah,
and use that for your laptop? I don't think so.
correct.
So clearly, cloud vendors are using unique SoCs to build a better network.
Mm-hmm.
They publicly announced their use of unique SoCs for accelerators of different kinds. So using accelerators doesn't defeat the purpose of vRAN. vRAN is really designed to build a more cloud-like architecture and take advantage of IT technologies. And if you look at all the major cloud vendors, they're using unique hardware solutions, and that doesn't at all detract from their ability to take advantage and build very scalable software on top of that. And that's what we really want to do with vRAN.
So, in other words, you're saying if there is enough volume and economies of scale, architectures will kind of give the same benefit as off the shelf that to be had. You're saying, right? Or
In fact, again, in terms of cost and power consumption, the optimized solution are better
Mhm.
than generic off the shelf, right? Because the generic off the shelf is generic, by definition, it consumes more energy, and typically it's more expensive than something that is specialized. But specifically, the use of accelerators, it doesn't detract at all from building cloud-like architecture and leveraging IT technologies. And this is really the purpose of vRAN. The purpose of vRAN is not to use off-the-shelf hardware. By itself, think about it. Using off-the-shelf hardware is not a purpose. The purpose is to build a better network, one way or another. And that can be more optimized for power, more optimized for cost, more optimized for management, ease, a lot of justifications, a lot of different types of what constitutes a better network. But use off-the-shelf hardware by itself doesn't make anything better.
I think the whole idea was that if it is true off the shelf, then it is cost can be optimized. But again, whatever cost benefit you might get with off the shelf would be lost in terms of if it uses more power and such. And if you have economies of scale with accelerator, for example, then you get the same benefit but with the better performance and with better power efficiency, right?
Yeah, but the argument that off-the-shelf could allow you to reduce the cost is an argument of one of our competitor. In reality, that's not the case.
Okay. Anyway, so Marvel announced the optimized, compute silicon for DU and RU at Mobile World Congress a couple of months ago. So, could you tell us more about that?
That's right. We announced the Octeon10 Fusion portfolio, and that's silicon that is optimized, as you said, for the distributed unit and the radio unit. It includes a lot of accelerators that are designed for those specific environments. To begin with,
Mm-hmm.
it's not just general compute, but it's also a lot of DSP capacity. The nature of radio processing and digital signal processing is that involved a lot of DSPs. So part of these SoCs, we've got a lot of DSP capacity in them, as well as very specific accelerators to help with the receiver chain on the DU, to help with beamforming logic on the RU, and the necessary interfaces with all the flexibility to connect a DU to an RU with the variety of ORAN splits that we discussed earlier, anywhere from split 7.3 all the way down to split 6 and even split 2.
Okay. So I think you mentioned a little bit. So what are the specific optimizations that you have in DU and RU in your solution?
Yeah, as I mentioned, aside of DSPs,
Mm-hmm.
there are a lot of if you think about the logic that is in a receiver to be able to handle the signal that users are sending from a mobile devices distributed in the area of the base station,
Mm-hmm.
these signals need to be processed such that we can decode the message out of a lot of the noise that comes with the air interface between us and the mobile tower.
Correct.
And that involves a lot of coders, decoders, polar coders, Viterbi coders, right? A long list of algorithms
Mm-hmm.
that are implemented in hardware in order to ensure that, one, they're most efficient in terms of area and power consumption, as well as most efficient in terms of latency. As you know, these wireless networks are very, very well bounded by very minimal latency. So these are all important part embedded in these chips.
Correct. And that basically highlights why you need optimized hardware versus a CPU, which would basically, no matter what kind of inputs you give it, it would treat all of them similarly, which means the performance may not be the most optimal when you know that you are getting a specific type of or kinds of inputs to these processors, right?
Exactly. General purpose compute in general can do most things, but it
Mm-hmm.
doesn't do them very efficiently.
Okay, so and Octeon 10 has been around for some time. I think it was introduced in 2021 and it's already been used by hyperscalers and so on. What is different between regular Octeon 10 and Octeon 10 Fusion used for vRAN and Open RAN?
Yeah, it's kind of in the name. The Octeon 10 that we announced in 21 is a compute platform that has a lot of accelerators for the TCP/IP network, TCP/IP, IPsec capabilities around deep packet inspection. These are functions that are used a lot in the processing of L2 and L3 in the mobile network.
Mm-hmm.
They're also used in standard networking equipment, routers, switches, things like that. Octeon10 Fusion builds on the Octeon10 platform
Correct.
and adds a lot of the L1 specific processing that we talked about,
Mm-hmm.
whether it's the DSPs, whether it's
Yep.
the codecs we talked about, or on the RU side, the beamforming logic and the interfaces to talk to the RFICs. So Octeon10 Fusion is a fused version between the Octeon 10 and all these new stuff that we added.
Very well. So that's where all of the optimizations and the radio functions you talked about, correct?
That's correct.
Specifically talking about DU, I know there are a lot of discussions on one architecture versus other. Where are the power efficiencies? How much, and so on. Any ballpark figure that you can provide for a DU with optimized silicon and with inline acceleration versus generic CPU based DU?
Yeah, that's a tricky question. You ask 5 people, you get 6 answers, and most of them are biased by whoever the particular person is trying to convince you.
Uh-huh.
So I'll try to avoid a specific number. There has been some data that was published in recent weeks.
Mm-hmm.
If you look at servers, they're expensive.
Mm-hmm.
They're very expensive.
Of course.
There are thousands of dollars. And clearly, you see that the traction in the market around vRAN that is based on standard off the shelf servers has been extremely slow. You pointed that out at the very beginning, right? Just the fact that you see a press release about one base station.
Mm-hmm.
So it's been very minimal, and I think that tells you that it is just very different. The figures of power consumption,
Mm-hmm.
the figures of cost on equipment that is optimized for the radio and the DU environment are just so much better than these general purpose solutions. So without getting into the specific numbers, you see that the operators who are very concerned about cost and power consumption, let's not underestimate
Mm-hmm.
the importance of power. Today, every chip company will tell you this is the number one consideration by all our customers, especially in this environment in which we live, where sustainability and energy efficiency is just so important.
Correct.
The CPU, the general purpose compute architecture, just doesn't come close.
Yeah, very well. I think there will be operators who will have kind of identical deployments where they can actually see the difference and then come forward with those numbers. We'll still have to see because a lot of the CPU based deployments are yet to happen for vRAN. We'll see how that pans out.
Prakash, if you think about it,
And yeah,
the original idea
yeah,
with the general purpose compute, where the L1
yeah.
is running on the general purpose compute,
Mm-hmm.
that thing has already gone. No one is
Mm-hmm.
promoting that anymore. At this point, we are all moving to a specialized hardware that will run the L1, and now we are only talking about whether the L2 or L3 could run on the general purpose compute. So you see already the evolution to specialized compute. In the L1, that train has left the station. Everyone is using optimized compute on the L1.
Yeah, true. Okay, so now moving on to your partners. I mean, Nokia has been one of your closest partners. I've seen, you got done a lot of press releases with them. There was one at Mobile Congress as well, and a lot of demonstrations you did using Octeon10 Fusion, and you've done announcement with Samsung as well. Could you talk about some of the partnerships and how those are panning out in terms of commercial products and deployments and so on?
Yes, to some extent. Nokia has been a fantastic partner of us for a while. They've recently announced the AnyRAN, a collaboration around ORAN and vRAN with the hyperscalers and the server vendors.
Mm-hmm.
And this is based on products that they're developing using the RiffShark
Mm-hmm.
SoC that they developed in collaboration with us. All that was made available publicly. We did a lot of joint joint marketing with them around the Mobile World Congress. And they're building and promoting products that are leveraging the ReefShark solutions across their portfolio, including vRAN. One of the unique aspects of the solutions that Nokia is promoting, and that was discussed at Mobile World Congress, is the fact that the same ReefShark SoC is used on the vRAN as well as in the traditional network, allowing operators to enjoy the same performance, the same feature set on the new vRAN architecture as well as what they're used to in the traditional environment. You asked about Samsung as well. Samsung has been a fantastic partner of ours for a very long time, since even before Marvell acquired Cavium, where some of these products originated. And Samsung, again, like Nokia, has been developing multiple generations of products together with us. And again, they're using a similar concept where the same SoC is used in multiple of their applications across the vRAN and the traditional deployments. And the relationship with both these customers have been just fantastic over the years.
Yeah, I think as you pointed out, you were in their legacy products, and then in vRAN and OpenRAN as well. I think that makes the transition easy for them because they are well versed with the products, the tools, software, and so on. So moving over for them becomes a little bit easier compared to doing with somebody totally new, right?
Absolutely. It's not just about ease, it's also about feature parity.
Correct.
Right? If you look at some of these new solutions that were trying to gain some traction, while they were working to an extent, they couldn't support all the many features that these networks have accumulated over 40 years of operation.
Of course. Yeah, indeed. Actually, I have written quite a lot on vRAN and OpenRAN. So, just a quick plug here if you want to know more about them and specifically on Samsung's evolution from a disruptor to a infra leader in US and other markets. Check out my articles on my website, www.tantraanalyst.com/insight. Again, tantraanalyst.com/insights. Okay, yeah, coming back to the partners, you also announced RUs with few players at Mobile Congress, right? Can you talk about that as well?
Sure. In general, there are quite a lot of companies that are using our products on the RU side. As I said, right, we've got a fairly broad portfolio
Mm,
of solutions ranging from ASIC DFEs all the way to the massive MIMO beamforming applications and the L1 processing that is required as you for example move to a split 7.3
mhm,
architecture. But specifically at Mobile World Congress, we've announced the next step of our partnership with ADI, Analog Devices,
mhm.
and we brought to market a reference design for a massive MIMO radio unit that makes it really easy for some of the newcomers to the space
Mhm.
to get up to speed on massive MIMO. It's a complicated technology. It's not easy to build a massive MIMO radio.
Of course, yeah.
And everyone in this industry wants to build a better massive MIMO radio because that gains traction nowadays with the operators as we are moving to higher frequencies. Massive MIMO is really important to be able to keep up with the distances
Mhm.
that we've been used to in the low frequencies. After all, operators cannot afford themselves to build more towers to put more radios. They can put more radios on existing towers.
Correct.
So the radio has to keep up with the distance of lower frequency radios.
Mhm.
And in order to achieve that, massive MIMO is the tool to do that. So we are seeing increasing demand for massive MIMO radios. So the partnership with ADI is really to make it easy for those customers who want to step up to massive MIMO development, and we provide a complete board with software and solutions that allow them to do that.
Yeah, I mean, a good example is if you look at US, Verizon and AT&T, they got C-band spectrum, which is in 3.6 gigahertz range, and they are trying to use their existing side grid, which was built for 1900 megahertz of spectrum, and a lot of the gap in terms of coverage can be addressed with massive MIMO, right? So similar in Europe, a lot of the initial deployments are in 3 gigahertz. Traditionally, they had 1800 megahertz, the side grid, and so on. So yeah, I think massive MIMO, especially in dense urban areas and where there's tons of traffic, indoor penetration, and so on. I think massive MIMO is a must for many of these deployments, right?
Absolutely, absolutely. Otherwise, it becomes again very impractical to build more towers in order to deploy these units. So massive MIMO becomes a mandatory requirement.
And also, I mean, and when this whole vRAN, Open RAN started, the vision was will have hundreds of players, even smaller players, because you're lowering the bar for market entry and so on. And I think probably in DU that may not be the case, but in RU you can see some of that happening. That you will see more RU players, in my view, than DU and CU players. DU and CU will still be probably dominated by either existing or new large vendors, but RU is where I think we'll see a lot of variety, a lot of new and existing players coming in and playing, and which obviously makes the system integration a big challenge for the operators and so on. But that's the subject for another day. I think we are almost up to the end of the episode. I think we covered a lot of ground. Any closing thoughts?
No, I think we covered, as you said, a lot of interesting ground. I think this is a market that is still evolving, and we will see how it develops. One way or another, as I said multiple times throughout the show, this is going to be the domain of specialized hardware.
Very well. Thank you, Joel, for coming back and providing your insights. I think we are still at the beginning stage of vRAN and Open RAN cycle. There is much more to come. Hope to see you back again on the show in the near future.
Looking forward to it. Thanks, Prakash.
Thank you. So, folks, that's all for now. Hope you found this discussion informative and useful. If so, please hit like and subscribe to the podcast on whatever platform you're listening this on. Don't forget to check out the article I mentioned in the description and the previous episode with Joel on vRAN Open RAN subject as well. I'll be back very soon with another episode, putting light on another interesting tech subject. Bye bye for now.